Number 1 says write the balanced molecular equation for the reactants, indicate whether the products precipitate or remain in aqueous solution. So this is a double displacement, which means that our cations and our anions can swap with each other. Okay, remember they're in aqueous solution, which means that the ions are just floating around, bumping into each other. So sometimes they bump into each other, and if they form something that's insoluble, they'll fall out of solution. And if they don't, then they just keep moving around and bumping into each other. So our possible products would be silver combined with phosphate and sodium combined with nitrate. Okay. Now we have to look at the charges on these to see how they're going to combine with each other. The charge on silver is always a +1. The charge on nitrate is always a -1. Okay. If you didn't know silver was a +1, you could figure it out because the charge on the nitrate is always a -1, and I think I gave you that information on the back of the page. And then the charge on sodium is always a +1. It's in group 1, so it's always going to be a +1. And then PO4 is a polyatomic, phosphate ion, and it's always a -3. Okay, so we have a +1 here combined with a -3 over here. So if you wanted to write that there just to help you, you could put those charges up there. You can crisscross them. And that means you're going to have one of these and you're going to have 3 of these. So if you want to rewrite that, Ag3 PO4, and there's only one of them, so we don't put a subscript. Okay? Then over here you have a +1 for sodium and you have a -1 for the nitrate, so 1 and 1 gives you 1 and 1. And I'll go back over here and put these in, and we count everything up and make sure it's balanced. Okay, we have Ag here, we have Ag3 here. So we're going to have to put a 3 here in order to take care of the 3 silvers that we had to have to react with 1 phosphate. So 3 silvers, 3 silvers. That gives us 3 nitrates now. So we're going to have to put a 3 here in order to compensate for the 3 that we had put there. That gives us 3 sodiums, which we already have, so that works out nicely, and 1 phosphate, which we have over here. So there's your balanced equation, a 3, a 1 understood, a 1 understood, and a 3. Now, the second part of that is indicate whether the products precipitate or remain in aqueous solution. And we know that anything in group 1 is always going to be soluble. So this guy right here tells us that this will be aqueous because it's going to dissolve. Nitrates also always dissolve pretty much. So that one is for sure aqueous. Then the other one, silver phosphate, that one we're probably going to have to go look at our solubility rules to see. And if I look at my solubility rules, I see that rule number 5 says that phosphates are insoluble except for rule 1. And rule 1 is anything in group 1. Silver's not in group 1, so that means that this guy is going to precipitate. So we're going to put a little S there to tell us that that one is a solid. And that's the answer to number 1. All right. Question number 2 says write the complete ionic equation for the above reaction. And this is the reaction that we just did in number 1. So we just go through and we have to break up each compound into its anion and cation. And remember, the cation is always first. That means the plus ion is always first. And it's always going to break down after that first element unless it's the positive polyatomic ammonium ion, which that would be the exception. But other than that, you're pretty much always going to cut them right there after that first element. All right? And you know that the first one is always going to be positive. Second one's always going to be negative. So we have 3AgNO3. That means we're going to have silver ions, and silver has a +1. You've already figured that out from your question number 1, hopefully. There's 3 of them, so we've got to put that 3 there. Okay? Then we've got the nitrate ion, which is always a -1. There's also 3 nitrate ions because this coefficient is for this whole thing, not just for the silver. So you've got to put a 3 there. Now you've got sodium, which is +1 always because it's from group 1. And that little subscript 3 means that in this molecule there are 3 sodiums attached to this phosphate ion. When they break apart, those sodiums are no longer attached to each other or to the phosphate or anything else. They're all in that solution freely running around. So that 3 is going to be put here to indicate that there are 3 of these ions now free in that solution. And then lastly you have the phosphate ion, which is a -3. Okay, and that information was on the back of your page. So those are the ions in solution on the reactant side, and each one of these is aqueous, which means they're dissolved. Now, on your product side, we have AgPO4S. Now, I drew a line there, but this is a solid. It's a precipitate. So this does not actually ionize. So I'm just going to go through and get rid of that because there is no separation of this compound. It is sitting in the bottom of the beaker just like that copper that we made in the lab. Sitting there, and it's not ionized, it's not roaming around freely, it's not running into all these other things. It's just a solid. So that's the way we're going to draw it, or write it. Ag3PO4S. Okay? And then we have the sodium nitrate, which is aqueous, which means that we're going to have free ions in solution. Once again, we have the Na+, there are 3 of them, and the NO3-, and there are 3 of them, okay, because that coefficient 3 is in front of all of it. And these are also aqueous, so they get the little AQ next to them. All right, so everything broke apart except the silver phosphate, which is a solid. So that is the complete ionic equation for the above reaction. It shows everything that's in the solution that exists as an ion. Question number 3, write the net ionic equation for the above reaction. So in this, we're going to write out the ions on this side that actually react to form the solid precipitate. And then on this side, we're going to write the solid precipitate, and everything else is going to be crossed out. Those are spectator ions. In other words, they did not take part in any reaction. So they're the same on the reactant side as they are on the product side. So we just get rid of those guys. So let's just go through first and get rid of the spectator ions. We have 3 NO3 here, and we have 3 NO3 here. And we have 3 Na+ here, and we have 3 Na+ here. Now once those are gone, everything else can be put down in the net ionic equation. So we have 3 Ag get your little charge plus PO4 -3 yields Ag3 PO4 solid. Okay? And that is the net ionic equation. That is only representing the ions that actually reacted and formed a product. So that's the answer to number 3. Okay, question number 4 says, remembering that the production of water is the driving force for acid-base reactions, write the balanced molecular equation for this double displacement acid-base reaction. So basically it's saying you're going to produce water and something else. Double displacement, you're actually going to swap your cations and anions. And so NO3 and Na form NaNO3. Don't make the mistake of putting the NO3 first just because it's first in the equation, because you always put the positive ion first. So sodium's always going to go first, and then you have H and OH. And another way of writing HOH is to write it as H2O. Okay? So HNO3 plus NaOH yields NaNO3 plus H2O. And it looks like that is balanced just as it stands there. So that would be the answer to number 4.